All right, all right, all right. Today we're talking about additive relationships, additive relationships, additive relationships. What's the first part of that word additive? Add. We're going to be adding in our problems today. Positive and negative numbers. Adding and negative is subtraction. So today we're going to be talking about additive relationships. We're going to look into the graphs, we're going to look into the tables, we're going to look into the word problems, the equations that all are geared towards additive relationships only. Additive relationships only. Before we get into what makes an additive relationship, let's real quick review that our equation is in the form y equals x plus b. You don't have to write this down, don't worry. I'm just talking through some things to make sure we're all on the same page before we get into our notes today. What makes an additive relationship? An additive relationship is, again, that we have addition. We are adding this letter B. We are adding this letter B, and we call this letter B our y-intercept. We're going to write all this information on our notes, but I just want to talk through it first. So just have your focus with me right now. What makes additive and multiplicative relationships different is that we are adding this letter B. We're adding our y-intercept. In case you forget a graph, I printed one out to show you. Our y-intercept is on our y-axis. Remember, this vertical line through the middle of our graph is called our y-axis. The horizontal one is called an x-axis. But we're not worried about x right now. Right now, we only are concerned with our y-axis. And in an additive relationship, I'm going to have a line that goes through my graph like this. And this point right here, where my graph line crosses my y-axis, that one tiny point right there, that is my y-intercept. That is my B. So when you see these equations, when you see these tables, when we're talking about the y-intercept, when we're talking about the B, we're talking about this tiny little point on a graph. We're talking about that tiny little point on our graph. Now that we've talked about all these ideas, let's put them on our notes. Additive relationships, additive relationships. Sorry, it's fun to say. So, again, our y-intercept is where a line crosses the y-axis, not to be confused with the y-value. The y-value, when we graph points, when we have our coordinates x comma y, we're not talking about this on like a table. We're talking about this on a graph. So again, our B is the exact same thing as our y-intercept. B means that it is my y-intercept. That is that one tiny little point where my graph crosses the y-axis. That is my B. That is my y-intercept. Those are synonyms. They mean the same thing. So we've got two examples over here where we want to try to find the B in our equation. Again, the B is whatever is added or subtracted to our x. So example A, we have y is equal to x plus 9. What number is added or subtracted to my x? 9. So our B equals 9. Example B, y is equal to x minus 5. Here, what do you think our B is? Our B here is minus 5, negative 5. The reason that is because if I really wanted to, I could rewrite this equation as y is equal to x plus a negative 5. That's too much work to write x plus a negative 5. Because if I add a negative, I go to the left on the number line. And if I subtract, I go to the left on the number line. So it's the same thing. So here this was a positive 9. Down here this is a negative 9 for our b. A negative means that it's below the x-axis. A positive means it's above the x-axis, or the x-axis. Positives and negatives just help us see where on the line things are. So for example, again, you don't have to write this down. Our first one, our b was equal to 9. So that means that one tiny little point would be at 1, 2, 3, 4, 5, 6, 7, 8, 9. That one little point there, that would be my b for example A. Because it's a positive 9, I go up. Here my b was a negative 5. So from my origin, I would go down 1, 2, 3, 4, 5. And my b, for example, b, would be down there. If you need help, if you need review with graphing, take a look at the last page of the playlist because there's some activities there to review graphing for you if you need that. So flip to the back. We have some example problems. Y is equal to x plus 7. What is my b in that equation? 7. What is my b in 2? X plus 1/2. What's my b here? 1/2. Your b can be a decimal. Your b can be a fraction. Your b can be a mixed number. Your b could be a square root. Your b could be scientific notation. Your b could be any kind of number. Any kind of number at all. It's not always just positives and negatives. What's my b on 3? Y is equal to x minus 10. That negative's got to stay with it. So my b here would be negative 10. And then 4, x is equal to x minus 4. What's my b here? Minus 4. Our b is whatever we add or subtract to our x. If you need to pause the video to go back rewatching that, go ahead and be my guest. Otherwise, we're going to come back to our set of notes where we're talking about our table of values. I'm going to take a quick drink break. Starbucks. The Starbucks Strawberry Acai Refresher, the unofficial drink of Miss La Rosa. But if they sponsor me, I won't get mad. All right. So now we're still taking a look at B. We're still taking a look at what makes additive relationships different and special compared to multiplicative relationships. That B, that y-intercept, that number that we add. In a table, we look for B in kind of a different way. We look for our B where our x is equal to 0. We look for our B where our x is equal to 0. It says look for 0 in the x column or row. So here's my 0 for x. Here's my 0 for x. Your y-intercept, your B, is the ordered pair that is created using those 2 points. So in this example, 0, negative 4, my B, that point where my graph crosses the y-axis, that one tiny point here, my B would be negative 4. If they are just asking for B, they're just wanting that number that would go in your equation. Then here, they want us to write the ordered pair that goes along with that B. The ordered pair, in case you forgot, ordered pairs are written the x number first and then the y. X and then y. Alphabetical order. The x number comes first, then the y value. So where my B is located, my x is at the point 0, and my y is at the point negative 4. And I want to write my ordered pair like that. Again, where's the x equals 0 here? It's at the end when my x is equal to 0. Its y is my b. When x is 0, my y is b. So what is my b here? 6. If this was an equation, my plus b would be plus 6. Now we need to write it as an ordered pair. Your y-intercept ordered pair is always a 0 first, because 0 is my x comes first, and then my y would be 6. 0, comma 6 is the location on my graph. It's always where your x is equal to 0, because on my graph, on this y-axis, my x value is 0. On my y-axis, my x value is 0. I don't go to the left or the right. I only go up or down from my origin. If I only go up or down, that means I only have a y value. I only have a number in the second spot and a 0 in the first. Let's flip to the back side and do some more examples. We're going to jump down to 7 and 8. That's where we see that we have these tables. So again, what are we looking for in our x to help us find our b? We're looking for the number 0. We're looking for the number 0. This set of coordinates is what we're looking at. So when x is 0, what is my b? What is my y here? Here my b is equal to a positive 4. Now they want an equation from us. Now they want an equation. Remember, additive relationships are in the form y equals x plus b. So we need to take this information and substitute it into this equation. So we would have y is equal to x plus 4. Y is equal to x plus 4. Go ahead, pause the video, try 8 on your own. Try 8 on your own. Write out what is b and what equation would you get with that b. Hopefully you get that your b is equal to 15. So your equation is y is equal to x plus 15. What's nice about our equation in our table is we can see this pattern of our equation within this math. If I take my x and I add 4, I will get my y. 0 plus 4 equals 4. 1 plus 4 equals 5. 2 plus 4 equals 6. 3 plus 4 equals 7. The math works. Over here, 0 plus 15 equals 15. 1 plus 15 is 16. 2 plus 15 is 17. That's another way that we can figure out our equation. What number are we adding over and over and over again? That b, that number that we add over and over and over again, is what I'm adding in my equation. If you need to pause the video, go ahead and do that for me. Rewatch, pause the video, write down anything that you've missed. Otherwise, let's flip back to our last section that we have here, the graphing section. Let's take a look to see what b looks like on our graph again. Now for our graphs, again, we want to find where the line crosses the y-axis. Your y-axis is your vertical axis. Vertical means up and down. Vertical means up and down. So this is my y-axis, the one that goes up and down. This is my y-axis, the one that goes up and down. Wherever my line crosses that, that is my b. So on this first example, here's my line, here's my y. This point right here is my b. So now we need to count. What number is that? We always want to count from the origin, this point in the middle of my graph. And if I count, I go up 1, 2 spaces. So my b is going to be a positive 2 because we went up. If we go up, that's positive. If we go down, that's negative when we're counting for our b. So now our coordinates for that point, our coordinate for that point would be at the point, my x is 0, 2, because I just go straight up 2. This next one, what direction do we go from our origin for our y-intercept here? Now we're going down. We go down 1, 2, 3 spaces. How do we show that it's going down again? We write that 3 as a negative. Because like we said over here, if we go down, that's negative. If we go up, that's positive. Because we went down 3 from that middle, from the origin, it's a negative 3. So our coordinate here would be our x. We don't go left or right, so it's just a 0. And then negative 3. 0 and negative 3 because we go down 3. Now let's take a look at the very bottom for some example problems. If it helps you to use a highlighter for your y-axis to help you remember where to look, please use it. Please use a highlighter, use a Sharpie, use a colored pen, anything that's going to help you remember where to look. So here our b is going to be what number? Negative 2. We went down 2, so it's negative because we went down. So now we want to fill that into our equation. Again, y equals x plus b is our equation. We need to substitute b into that equation. So it should be y is equal to x minus 2. If you wrote y equals x plus a negative 2, that is also correct. You just won't see it that way on a test. On a test, you would see it as y is equal to x minus 2 because it's easier to write. Pause the video, try this next one on your own. What would b be, and what is the equation? Hopefully you said your b was 1, 2, 3, and a positive 3 because it was up, making your equation y equals x plus 3. Y is equal to x plus 3. We skipped 2 word problems up top. I want to see if we can figure out what the b is based off of what we know. We know that the b is the number that we add or subtract. So when we're looking at these word problems, be thinking to yourself, what number am I going to add or subtract? Looking at number 5, it says Ella started with $5. She earns $1 for each additional chore she completes. What number are we adding there? What would our b be? Our b would be 1 because we are adding $1 for each additional chore. So our equation should be y equals x plus 1. She already has $5 that she's starting with, and we're adding 1 each time. Try 6. Try 6 on your own. The ice cream shop charges $3 for a scoop of ice cream. Each topping is an additional $1. What is your b, and what is your equation? Your b should be 1 again. An additional $1 for every topping. So our equation is going to be y is equal to x plus 1. If you have any questions with this, let us know. Good luck on your practice.